Welcome to today's tutorial. So today we'll be looking at our refraction through lenses. So in our last video, we talked about refraction through triangular prism, and we've seen through a rectangular prism as well as mirror. So make sure you like and subscribe to this channel to get more of this video. So today we'll be looking at refraction through lenses. Now, a lens is any transparent object having two non-parallel curved surface or one plane surface and one curved surface. So it's either you have two non-parallel curved surface or you have one parallel surface and a curved surface. So any material that has that property is known as a lens. Then the types of lenses, we have majorly we have two types, which is the convex or converging lens. Then we have the concave or diverging lens. Uh, so this is a convex lens. A convex lens is thinner at the edge. So the edge is thin and the center is thick. While the concave, the edge is thin, is thick, and the center is thin. So that's the difference between this. They are both transparent materials. So then other types of the lenses we have plano convex, in which one side is straight and the other one you have a curved surface. Then we have the plano concave and concavo convex lens. So these are the other types of lens. Now we said this is convex or converging lens. So that means any rays of light passing through it. If you have the lens this way, then we have what we call the principal axis. This line is the principal axis. Then this center here is called the optical center. Then a distance from the optical center to this, where we have the focal, this is the focal point. Then the focal point can be an integral multiple. That is, if we have one focal point here, we can have 2f. Then, since this is a transparent material, you can also have the focal point at the other side also, and so on. Now, any light that falls that parallel to the principal axis that fall at this point, they will tend to what? Converge at the focal point. Any ray that is, they will converge at this focal point. So that's why this is called a converging lens. Then for a diverging lens, that's concave lens, we'll have the same thing. Then if you have an object, let's say this F, this F, then any rays of light that comes this way, they will tend to diverge. To diverge, then if you have a ray, it will diverge. They will fall at this position here, and then the rays will diverge this way. So that's why it is called the diverging lens. Next, we are going to look at the location of images at different positions of an object. Now the first is object at a distance less than one focal length. So we'll start with the converging lens, that's convex lens. So if you have this is the convex lens, then we have our principal axis. this is the optical center. Then if we choose here as F, now the distance between F and C is known as F. That's the focal length. Then we have same distance 2F. We have the same thing F, then 2F. Now object at a distance less than one focal length. So at a distance less than F, so that means it can be anywhere within this region. So let's say this the object. Now rays of light will be transmitted through this way. Now it will now fall on the focal on F this way. Then rays from this object also that they will pass through the optical center. Now any ray passing through the optical center will not be deviated or it will not be refracted. So it will just pass through it straight. So from this to this. So clearly you will see that this side, these two lines will not meet. So then this, if we draw it this way, they will meet here. So this is where the object, the image is formed. So you can see our image, this is the object. So this is where the image is formed. So we can look at the properties or the characteristics of the image that is being formed. One, you can see that the image is bigger than the object, so we can say it is magnified. Another thing is that the image is standing upright with the object, so we can say it is erect. Then another property again is that you see for lenses now, unlike mirror, the image is supposed to be formed at the other side. That is, if the object is placed at one side, the image should be at the other side. But in this now, the image is formed at the same side as the object. So therefore, we'll say it is virtual. Then, where the image is formed, you can say it is formed between F and 2F. So those are the properties of the image formed at that location. Now the next is we look at object at F. So draw a convex lens. Then this is your principal axis. Now, so we have F, we have 2F, we have F. So the distance between C to F is same as the distance between F and 2F. So we said the object is placed at F. These are objects at F. So rays of light will pass through this way. Then it will fall on the principal, on the focal point. So we have it this way. Then light from the object will pass through the optical center. So from here to here. Now these lines will not meet. So if I extend this and this, also you can see we have two parallel lines. So therefore, the properties of this is that the image is formed at infinity. So the image is formed at infinity. So number 3, let's look at object at, so object between f and 2f. So now I want to look at object that is placed in between f and 2f. That is a distance greater than f but less than 2f. So this is the object, then this one, then it will fall on f. Then from the top of the object pass through so we'll say so this is not drawn to scale. Uh, okay. So object is formed at this position. Now let's look at the properties. So this image. Now the properties of this image. One, we can see that the object is formed. This is where the object is and the image is at the other side. If that happens, we have a real, so the image formed is real. Then 2, you can see that, look at the arrows, they are inverted. So the image is inverted. 3, the image is magnified, so it's bigger than the object. Then 4, what other property do we have? You can see where the image is formed. The image is formed beyond 2f. So the image is formed beyond 2f. So those are the properties of the image formed by an object placed between f and 2f. Then next we look at object placed at 2f. Now our object is at 2f. We cross this way, then again from the center, uh, from the top of the object to pass through the center. So this is where the object will be formed. So let's look at the nature of the image. So let's look at its properties of nature. So one, it is inverted. Then two, uh, if you actually draw this to scale, that is, if my distance from here to here is the same, you should be getting the image will be the same size as the object. Now, again, image placed as 2f is the same. It will be formed at 2f. That is, if you place the object, if you place your object here, the image will be formed here. If you place the object here again, it will be formed at the other side. Now, any image formed at the other side should be what? So it should be ray. So that's the nature of the image formed by an object placed at 2f. So next, uh, let's look at object placed beyond 2f. So object placed beyond 12. So we've been using this side, placing an object at this side. Note that you can place your object at any position, either this side or this side. So let's use this side now. Let's say place beyond 12. So this distance from here, this is beyond 12. So let's have our object placed at this position. So we are having this. So that's our object. So it will go this way. Then this. The lines actually are not that straight. So let's take it this way. Now, if we draw this with a great precision, we should be having the following properties. So, one, the first property you're having is the image formed will be smaller than the object. So say the image will be diminished. Then two, it is inverted. Three, uh, the image is inverted. Then it is formed between F and 2F. Then 4. What else do we have? Since it is formed on the other side, so it is real. So those are the properties of image placed beyond 12. Now, what if we have a special case whereby the object is at infinity? When we say object at infinity, we just mean when the object is far from the object, like very far, not that far actually. So if we have object at infinity, let's say these are the ray of light coming this way. So, okay. So since we don't know the height, so let's say the ray of light is coming. So this will bend actually. Then the characteristic is that so one property is that the image, any object at infinity will always produce the image, so the image will be formed at F, that's the focal point. So those are the properties of image that can be formed or produced by a converging lens, where the objects are placed at different positions. Now let's look at how images are formed by by a diverging lens. So for a diverging lens, that's concave. So if we have object, if we have an object placed on one side of a converging lens, this is the only image that will be formed. So we have rays of light this way, then they will converge at this same side as well to now diverge this way. Then we send ray from uh, the object will pass through C this way. So at this point when they meet, that's where the image is formed at this place. So the properties of the image formed are One, we can say it is erect. Now, it is formed at the same side or where the object is. So this object, they are formed at the same side. So it is, we will say it is virtual. Then we can say the image that is produced is smaller than the object. So we say it is diminished. So those are the properties uh, of the image formed by a diverging lens. So thanks very much for watching this video. Make sure to hit the like button and subscribe to this channel to get more of it. So thank you very much. See you next time.